So in this session, we'll discuss about the how to write a test bench. Okay. So last session we discussed about the how to write a Verilog HTML coding for half adder and full adder using data flow modeling. Okay. In this session, how to write a test bench, how to validate your design, how to simulate your design by giving a test vectors. Okay, simulation is nothing but you are verifying your design by giving a proper inputs to validate your output whether it works or not. So instead of for that in the Verilog HDL, you can write a .v file test bench file also. You can simulate all the test vectors, all possible test vectors, and you can validate the output. So write a test bench to validate your design. For that, first we'll discuss about the half adder. Okay, right click, new source, open the new source. Here, instead of Verilog model, you choose the Verilog test fixture. Test bench. If you want to write a test bench for this half adder, choose this Verilog test fixture and give the file name. So at the beginning, whatever the names I'm giving for understanding purpose, you follow the same. Later on, you can give your own names. So the file name, what are the file name we have? So half adder HA underscore data flow modeling. Now I'm going to write a test bench so that you give a file name TB test bench. Just whatever the sources files are created underscore TB. So this is not a keyword. Okay. So you cannot give the file names, module names with the numbers. Only you can start with the alphabets. The underscores are allowed. So for understanding purpose, I'm given HA underscore data from modeling underscore TB. Okay. Then next. Then here, see the source files HA and HADF. Okay. HA half adder underscore DF. FA. Okay. Half adder. And here we are doing half adder. Then next. So what is that source type? Text fixture and source name is .v file for test bench. Okay, the associated with the HA our. Then finish. Now this coding window, if you note down, again the Verilog file is created for your test bench. So it is created. So you have to, this is generally it is created with your test bench name. So in detail, we have to give all the test vectors. I'll teach you how to write a test bench for this code. Okay. Now, so if you notice in the test bench, module name. What is the model name I created? HADF underscore TB. This is a model name is created. Test bench file is created. Okay. If you notice here in the test bench, there is no terminal list. There is no open the bracket, close the bracket. They specify the IO ports list. It is not here. So by seeing the Verilog coding, this is a test bench we have written for the half adder. Model name. There is no IO port terminal list. You can give the comments here. So here also you write all the comments. Okay. You write all the comments here. So here I am writing only test bench or half adder. Okay. The remaining things you can add whatever. Test bench for half adder. Okay. So whatever data flow modeling or gate level modeling, whatever different modeling styles you have written the code, but test bench is same because test bench is half adder, black box, two inputs, two outputs. The possible test vectors for half adder, for example, A, B, two inputs, four possible combinations of the test vectors, either 0, 0 or 0, 1 or 1, 0, 1, 1. So with these four combinations, you are going to validate your design, whether it works or not. For that, you are writing a test bench code here. Okay, dear. So what are the rules you have to understand in the while writing the test bench code? So first line module name. There is no IO port terminal list. Okay. Here I can give the comments. So created the test bench created a test bench with a module name, module name without port list, without port list. Here I am not specifying any port list. We are going to instantiate our design. What is our design? First design HA, half adder. For example, here I written the code for half adder. I am going to validate the design half adder. I am going to validate how you are going to instantiate this half adder under unit test. Okay, so you are going to instantiate this half adder and you are writing a test bench. So in which the rules are you have to specify here you have to write a test bench model test bench name model test bench name you give without any port list. Then second step, what are the inputs you declare in the half adder? What are the inputs you declare in the half adder? So inputs are A and B. Here we are going to feed the input and verify. You have to feed the input. You have to store the input. You have to store the input and see the output. So for storing, okay, for that you have to declare the A and B as reg. The reg is a reg. Okay, so data type. So reg is a here. It's not a hardware register. So you have to it's a temporary storage. So you have to declare as a keyword reg. So what are the inputs you have declared? All inputs in the test bench declared as reg. So here I can give all inputs declared as declared as declared as reg keyword in the test bench how to write. So reg A, reg B. Similarly, what are the outputs you have declared in the program in half adder? S and C, same name, okay, A and B. So even your design, okay, what are the variables names are used for the inputs A and B? So that inputs, all inputs, I'm not writing here all A, B, inputs may be any variable name A, B or X, Y or P, Q, whatever. All inputs declared as reg keyword. And similar all outputs, okay, all outputs declared as wire, keyword. Wire is a keyword. Okay, so blue color C, blue colors model, reg wire as wire keyword, SNC. Then the next step, instantiate. Whenever you go for in working in industry, you have to write a commands for understanding purpose each for each and every model. Okay, only you can understand later. So you have to declare all the outputs as wire. S and C, the variables are for sum and carry. S and C were used. Someone you can use SUM, carry CARRY in the design. So whatever you use in the design, you have to declare all inputs as reg, all outputs as wire. So then instantiate our module design model HA under the test. So we are mapping. This is the syntax design your design main model, the module name, and this is optional UUT. Okay, or any optional name you can give. Open the bracket. See uh, dot. You are mapping the terminals of your input, your program main module, your design offer a design inputs mapping with the test. So these are the test input terminals. So I'm mapping. I'm giving the same. In order to avoid the confusion, either you can give caps also, capital S also. You can modify all editable code. These and all we are editing. So simply it is created. Okay, but you can write. You can write a complete test bench code here. So, but this is a syntax you have to follow. You have to instantiate the which unit you are going to test, after you are going to test. So, in that I am mapping my test vectors, okay, with the terminals. So, S and C, okay, C for carry and your inputs are A, and map with the ports list. Port mapping rules. It is very, very important. The port mapping, how we are defined in this output followed by input. Same way here outputs followed by inputs. So you can if you specify like this, it is not mandatory. You have to follow the ports. You can specify anywhere, but map it properly with these names: dot C of C, dot S of S, dot A of A, dot B of B. So here, so now I'm writing efficient because while taking printout, number of lines you reduce. So so that I'm reducing the number of lines. So in a single line, I kept everything. Okay. So I've added. Now you can give the test vectors. For that, the test vectors can be given between, so initial, begin, end. Okay. So this will be behavioral statements. So in the begin and end, all the statements will be run one by one. So first the test vectors I given A equal to 0 and B equal to 0. Okay, so then you give some, so during at 0 simulation, if you are not specified at 0 simulation time, it will take the values A equal to 0 and B equal to 0. Then I am changing the test vectors, wait for some nanoseconds, and you can give the another test vectors. So what are the another test vectors? I can copy this one. I can give here A equal to 0, B is equal to 1. Then again I can copy this. I can paste it here again. It will be 0, 1. This is now 1, 0. I can change the test vectors 1 and 0. Okay. Then again last test vectors A1, B1. Okay. So same line. It will, while taking printout, it looks nice. So module test bench name, all inputs declare as stage, all outputs are declared as wires, and instantiate the my design half adder. I'm going to verify the design. So mapping, port mapping is the you have to specify the port mapping properly, otherwise you will not get the result. Then the test vectors I'm going to give here. So in the test vectors, I'm specifying all the test vectors with the uh, time delay. So this is the syntax, the hash symbol. The hash symbol is used for, you have to specify the what is the, how many seconds you have to wait after 100 nanoseconds. Next 100 plus 100, after 100 means now 200, after 200 nanoseconds, after 200, then again after 100 nanoseconds, at 300, A is equal to 1, B is equal to 1. So you are specifying all the test vectors. Okay. So initialization, and I'm changing the test vectors after some delay. So this is the way to write the test vectors. Then end. So after all this, I can finish the simulation. So already in the theory class, the language constructs the system parameters. Okay. So the dollar sign finish, you can do the dollar sign finish, end with the semicolon. And you can, like C language also, you can use the this scan and the printf statement in the console window. If you want to do, you can use display command also. Okay, so here you can give the dollar sign. Display command is also the display command you can do. Open the bracket, you can specify what are the things you have to display on the screen by using the string command. So the string command with the start with the apostrophe, double apostrophe. I can say the input. Okay, input. Here input is A, no, input A equal to. So the input binary format, I can give the text vectors, no, input. For that, like in C language, get the value of input. Similarly here in HDL, get the percentage symbol, get the value of A. Okay, comma. Similarly, other input A, then input how to display in your screen. That is a string I'm giving input b equal to get the value of b. So percentage b. Okay, percentage b. I'm getting a value and b value. Okay, comma and display the outputs. So for displaying, simply this is all between the string when I'm giving. So you can give this symbol. Okay, I can give this one. So now I can type output. This is half at only output sum. Output sum. Output s equal to output a. Output sum equal to what is the output percentage of b. Okay, percentage of b, comma, sum is equal to what is the sum you can display. Similarly, comma, carry, carry, carry is equal to percentage of b. So it will be displayed on your console window screen. Okay, then you have to specify. So what are the things you have to get? You have to specify a comma, okay, a comma, b comma, you and s comma. So a comma, b comma, s comma, s comma, c. Okay, so in how we are giving the C language, similarly you have to give here double apostrophe. Okay, then a comma b comma c, close the bracket, terminate. So display all the inputs. Okay, then it will validate the test vectors and it will display all the outputs also. Okay, like that you have to write a test bench, add stimulus here. Okay, then finish after some. So begin, uh, so initial, begin and end, module and end module. The module is there, so end module. Okay, and end module should be there. Begin and end. There is no semicolon at the end. There is no semicolon at the end module. Notify. You can do some mistake. We'll do end module. Otherwise, see here some. I'll do some mistakes. Semicolon. Here I can do some semicolon. Okay. Shall we share the program? So save. See what are the errors it shows 28, 28. So 28 before that you can check. So now I can remove this one. Now I can remove debugging the coding without semicolon because the syntax it will show. If any syntax error, it will show the errors. So now I can save. Okay. So again, unexpected token, end model, end model, end model. Okay. Now I'll choose this one now. The check syntax you do. Okay, now we have completed the complete test bench for the half adder. So remember that how to write a test bench. So module name, there is no port list and all the inputs declared as reg, all the outputs declared as wire and specify the design which design here half adder you are going to test. So more port mapping is very important, map it properly. Then initial, begin and end, between this all the test vectors can be given for verifying your design. So some of the parameters, system parameters, display command for getting in the console window. You can see what are the inputs, how to get the input values, what are the values has to be displayed, and the possible test vectors you can give after some initialize with one test vector. After some delay that is denoted by the symbol hash symbol. as after some delay. What is the delay you are specifying? 100 or 10 or 50, whatever you can specify. After some delay, you are changing the test vector, and you are specifying all the possible vectors. After some time, after this simulation time, 100, 200, 300, you are finished the simulation, but terminating the simulation. Then end model. Okay, so we will validate the output for this test bench also. Okay, so instead of forcing one by one, we are doing, we are writing the test bench separately, and we are simulating all the test vectors. Okay, so hope that you understood how to write a Verilog code source file and test bench source file. So the simulation part, next session we'll see.